All right, so in this video, I'm going to do my absolute best to break down the hype around word problems when it comes to quadratic equations. I feel like we put a lot of effort into learning how to work with a quadratic equation, and then we kind of just assume that we know what we're talking about when it comes to a picture or a diagram or something. And I, as a student, just didn't make that connection. So if you get halfway through this video and realize you don't need this, feel free to just turn it off and move on. But otherwise, this could be helpful. Okay, so I want to really encourage you that when you're, working with a word problem, always draw yourself a picture. So that's kind of like your step one to success is draw a picture. And I'm going to say a really close, step two for success is take a deep breath. And be logical. Because you have a really good brain. And you know what situations look like in real life. You've lived so many years, you can figure this out. So just trust those instincts that you have and relax whenever you come across a word problem. So I'm going to break down what it might look like to have a word problem where you're throwing a ball or something like that. It's a classic problem when it comes to quadratics. So when I'm talking about throwing a ball, let's say, I don't know, I'm throwing it off the top of a building because I'm just crazy like that. I'm just a cool cat, right? Throwing a ball off a building safely where nobody else is around the ground. Okay, so let's say, I don't know, my building is 50 meters tall. Now, if I throw the ball upward, if I'm standing here, the ball's going to make some kind of a shape like this. Notice how we have a perfect, situation for a parabola. So notice here that your y-axis really represents the height of the ball, and the x-axis represents the amount of time passing. So after a while, the ball continues up, and then eventually it starts to come down. And that's all stuff that we feel intuitively without even being math experts. We just know that this is going to happen. Okay, so now let's break down a couple of things. When we work with quadratics, we learn how to find the y-intercept. We learn how to find x-intercepts, and we learn how to find the vertex. But what do these things mean in terms of a word problem? Like, what does it mean to have a y-intercept? Well, let's take a look and break this down. So our y-intercept happens over here. It's whenever your x value is equal to 0, or maybe in this case when time is equal to 0. So you're kind of looking at, x, sorry. So you're really looking at like when x is 0 or maybe time is 0. It's just whenever you're at a 0, nothing has happened. So generally, this y-intercept in a word problem is going to represent your original height or your original, amount of something. And so it's kind of that original space. Because no time has passed yet. So the ball started 50 meters up on top of a building, and then it went even higher, and then it came down here. So now let's actually talk about what the x-intercepts mean. Down here is where I'd find an x-intercept. By the way, quick note, I'm not really going to continue down because it doesn't make sense to talk about negative height. That would be like I don't know, your height could go down to 0, but then what does it mean to go past 0? It doesn't really make sense. So we don't usually draw the graph beyond that. We also don't draw the graph beyond here because that would kind of be like going backwards in time, and that just doesn't really make sense either. So you're generally going to see that your word problems happen only in the positive areas. So positive time and positive height. We don't go into the negatives. Okay, so what would it mean to be at an x-intercept? Well, the x-intercept, if you're thinking about a ball traveling through space, is technically where the ball would hit the ground. So the x-intercepts generally represent the time when the ball hits the ground or something like that, when your height or whatever is equal to 0. So your height is 0 or your y value is equal to 0. This could also be talking about money. Let's say you're spending money, so you started saving and you have an increase, but then you start spending money and geez, now you have no money left at all. So just think in terms of this is your 0 amount. You have nothing left. You have no height or you have no money. And this is how much time it would take you to run out of that. So, if your word problem is saying, hey, when does the ball hit the ground? Or when do you run out of something? That's what your x-intercept is telling you. It tells you when that happens. Okay, so now let's talk about the vertex. Let's say you are following the trajectory of the ball, up, 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 here it goes, and at the top is really where your vertex is. And so what do you think a vertex would represent? Well, it's going to represent either a maximum or a minimum. Imagine your parabola was turned upside down, you would get like a minimum down here. But since it's this way, you're really looking at the maximum height. So I want to point out a couple of things. When you find the vertex, you're going to have an x value or something against like your traditional x-axis. That would tell you like when the ball hits its maximum height. So that would be your time at the maximum height. But it doesn't actually tell you how high the ball is. So this could be something like t equals 5 seconds. So you know that after 5 seconds, the ball has reached its maximum height, but you don't actually know what height that is. So be really careful what the question is asking you. If it says what is the maximum height, well, then you got to go and take this and plug it back into your equation and actually find what that maximum height is. If they're just saying, when does it hit the maximum height? Well, then that answer is fine, right? Because that's your when. So those are essentially how, these three key features that we've been working with relate to a real life context. Sorry, your vertex is going to be either a max or a min value. And so I want you to think in terms of approaching these problems and understanding, first of all, what the question is asking. Draw a picture for yourself and label as much as you can. Use your really good logic because you have it and you need to start trusting yourself. Especially if you get anxious with word problems. Just take a moment to be like, I understand this, it's okay. And then you can find what they're really asking for. Your initial position would be your y-intercept. Where does the ball hit the ground, or where do you run out of, let's say, money or supplies or something? Well, that's when you have 0 of the amount. So you plug in 0. If you're looking for your vertex, then talk about a max or a min. But I want you to keep using the good skills that you've learned, how to find y-intercepts, how to find x-intercepts, how to find your vertex, and then you're going to nail these word problems. So no worries.